Hello guys, welcome back. So in this video we are going to see the shortest path in graph, right? So before that we have already seen a couple of videos, right, where we have observed the graph representation. First we have seen the graph representation, right? And then in the graph representation we have done in two way, right? The first the graph traversal, right, how we are going to traverse the nodes of the you can say of graph, right, or vertices you can say. So we have seen BFS, right, and DFS, right? But in the representation also, right, we have seen how to represent, like we have seen what is called a matrix, through the matrix and through the linked list, right? We have already seen. So if you are new in this video, so we are going to do a shortest path in the algorithm, where we will use a couple of algorithms, right? So the basic knowledge you should have the sorting, what is sorting and those things, right? But we want to see the shortest path, right? We'll see the shortest path in the graph, right? We'll see. So there is a couple of ways to find the shortest path from a single source to all other vertices, like we have the Dijkstra algorithm, right? So it is called single source shortest path, right? Or you can say another is all pairs shortest path, that we will see. All pair shortest path. Okay, so we'll see the single source shortest path algorithm, that is called Dijkstra algorithm, right? And then we will see all pairs shortest path algorithm, that is called Floyd-Warsaw's algorithm, right? We'll see that how we are going to understand the algorithm and the implementation, right? So in this video we'll see here the Dijkstra algorithm. If you have already aware with that Dijkstra's algorithm, right, we'll see in this video, or in the next video we'll see Floyd Warsal, right? If you remember these things in your college time, right? Algorithm, or you can see. Okay, so two things is here. The first is single source shortest path, and another is all pair shortest path, right? So we will see in the shortest path in graph lecture. So this is our lecture name, and we are going to see single source shortest path through the Dijkstra algorithm, right? We have already seen through the graph representation through the matrix and the you can say list, right? We have already seen where all the neighbor nodes we are storing in the matrix, another in the list, right? Okay, so we have also seen the graph traversal. This is the graph traversal, right? So graph traversal we have gone through BFS, and in the last video we have seen the DFS, right? So in this video we are going to see the Dijkstra algorithm, single source shortest path algorithm. So basically if you go for the interview, right, so in interview it will say find the shortest path from a single source, right, to all other vertices, right? All other vertices from, it will be there will be multiple nodes, right? Let's suppose like this. Okay, or there will be here or one more. So what will happen if this is a source and this is the destination? We have to find the shortest path, right? Shortest path algorithm, through that we have to pass. So if you talk about the shortest path in the graph, so shortest path algorithms are designed in such a way to find the minimum distance between two nodes, either the source or we talk about the destination, right? So between the two nodes we have to find the minimum distance, right, in a graph. Okay, so it depends on, or you can say it depends on the type of graph, right, basically. And there should be some specific requirements, like there can be many algorithms that can be used to find the shortest algorithm, like the Dijkstra algorithm or Floyd-Warsal algorithms, right? Or there is more Bellman-Ford algorithm is there, right? You can also use A star algorithm, right? or you can use BFS algorithm, right? So I want to say there is a couple of things that you can through that you can implement. Give me 1 second. Okay, so I want to say there is not only a Dijkstra algorithm and flood algorithm, right? Flood Wursel algorithm, right? But there is more than this, right? You can use Wellman-Ford, if you remember, right? Wellman-Ford algorithm, right? Wellman-Ford, Dijkstra, Flood, and one more was there, A star, right? A star algorithm, right? Either of these you can use the algorithm and you can do, or you can, there is one other that we have already talked about, BFS, right? We have seen already this one, right? So any of these 1, 2, 3, 4 and 5, right? Or any of this you can use, right? Any of the algorithm you will use, and you can do that. You can implement that, right? So what is the difference between this algorithm, right? Okay, so when we talk about the Dijkstra algorithm, right? Let's suppose we'll go with the Dijkstra, right? So in the Dijkstra algorithm, you can say it works well for the graph with non-negative edge weight. If there is no negative edge weight, means all are positive weights, right? If weight are given, let's suppose it is given here 5, here given 6, 7, like that. If you given, then it is good, right? In the Dijkstra algorithm, so it will work perfectly. But if there is -1, something -4, right, then it will not work perfectly. Okay, so and if you talk about the time complexity, right, so it will go for let's suppose TC, right? So TC will become what? V plus E, means vertices and edges. It will count all the vertices and edges, right? In the best case, it will become log V. Okay, so completely if we'll talk about, this will be your Dijkstra algorithm. So in the BFS we will use V plus E in the DFS, right? Remember. So if you use this Dijkstra algorithm, we'll go for V plus E log V. How we are going to do? We'll talk about this, because see, we will use a priority queue, right? And where all these vertices, number of vertices and edges are present, right? So we will keep looking for that, and we'll use priority queue for storing all these you can say vertices and the edges, right? So Dijkstra algorithm we use to find the shortest path from a single source node to all the other nodes in the graph by iterating the you can say or selecting the nodes with the smallest known distance, and we will update the distance to its neighbor, right? So let's suppose if there is 3 distances there, 5, 3 and 2, so we will prefer to go with 2, right? And then we will put into the neighbor one. Let's suppose it is already 3, so 2 plus 3 it will become. If it is 3, it is 4, right? Like that. So it will add here, right? It will add 2 like this. It will add 3 like this, right? Means there is a way in which what we will keep iterating the nodes, the smallest one, and we will add the distance, you can say update the distance to its neighbor, you can say, right? So that we are going to implement, right? Later we'll talk about Wellman-Ford, flood Wursel, right? BFS, A star. We'll go with one by one in this video. So keep watching these videos, right? Because if you want to understand the deep understanding of the, you can say, theory, right, then only you can implement the logic. Even you should have the concept clear, so that you can do more lead code questions, or you can say gigs of gigs or any other portals, right? Because if you do not have the concept, it is very hard to understand which concept we are going to use, right? So I will suggest, please watch this Dijkstra algorithm video, and if you like this video, please hit subscribe this channel. So let's go to the coding section and let's implement it. Okay, so now we are in the Eclipse, and let's go to remove all this, right? So first of all, what we should do, let's create a node here. I'll create a class. You can write above also, okay? I'll create a node class like this. See, why we are using node class? Because we have to uh, store the vertex and its distance, right? So if it is not there, right, if it is not there, then we have to write. If it is given, let's suppose in any portal, so see, is there node is given or not, node class is given or not. If not is it is not there, then implement it. Okay, so what I will do, I will write two things. I will go for write vertex, right, and then another should be its distance, right? Then we'll take distance. Okay, first we'll take node, another will take vertex. In node we'll take vertex and distance, right? Now we'll create you can say its constructor. Do right click, go to source, go to constructor, select all, generate. So this is your constructor. You can keep it or you can remove it. Okay, so I will remove it for understanding. So I have created one you can say constructor of the node. So whenever we'll create a node, we have to pass one vertex and one its distance, right? So then it will become what? This dot vertex equal to vertex and this dot distance equal to distance. So our object will be created. One node will be created that have the vertex and its distance, right? Now we should implement one more thing, right? See, how we will compare two objects, right? Two nodes, right? Based on the distance, right? Because if we will not compare two distance, how we will understand which one is shortest one or smallest one, you can say, right? To do that, what we should do, there is a class you can say interface, right? So to do that, we will implement what you can say an interface that is named as comparable, right? Comparable, right? This comparable method we have to call. Then you have to pass the type. Type is what? The current class node, right? Like this we have to do. But once you have implemented it, we have to implement its abstract class. So what is the abstract class? That we have to override. Go to here and right click here. Now you can see here we have our node class, our compare method, and we have to override this method. You can see here, right? So we have to override this method. How we are going to do that? See, let's suppose this node is nothing but our other node, right? This node is nothing but our other node. So here give me 1 second. Here what we will do, we'll return, whenever going to be return, we can or directly what we can do here, right? Directly you can write, no need to add one more variables, right? Go with integer compare. How we will going to compare? So integer dot compare, if you'll do, you can see there is a method int x and int y, right? So when we want to compare two integer value numerically, right, we can pass the values and it will return that we want to compare, right? You can see here, right? In this side you can see here, right? What is saying? Integer dot value of x compared to integer dot value of y. So when two integer we want to compare, right, then x is the first and another one is the y, right? So it will check. How it will check? If the value is 0, if both are equal to y, right? If the value is less than, then it will give 0, right? Like that you can see, right? If it is greater than, then like that. Okay, so I think you should be aware of this. Okay, this method. So we'll pass two things. The first is current class, current object we can get from here, the distance, and the other one, right, the other dot distance, like this. Two distance we will pass, the current one, and let's suppose this is x and this is y, right? Like that. You can see here, you can go to compare method, you can check, right? How compare will work? We have to pass x and y. So if x is less than y, right, it will return what? -1. If it is equal to, it will return 0, otherwise 1, right? So this is inbuilt function. Okay, I hope you understand, right? So this method is only to compare two nodes value, because we have to compare the nodes so that we can find the shortest one, right? Now let's go to here. We'll create the main letter, right? Let's suppose before that let's implement some code, the functionality, right? Or what you can do, you can create a main. Main we have already there. You can add some values like previously we used to do, that you can do, and then you can pass all the nodes, right? Let's suppose we have given int n. N is number of node, right? Let's suppose I will pass 5 node, okay, like this. Then if you need what we can say, graph, right? So we can put each node contains a list of node, right? So I can put like this, list of list, right? List of list contain what? Node, right? This should be a list of list, and that is called nothing but a graph, right? I can write like this, right? Or you can provide equal to new linked list, or you can say yeah, you can take linked list, or you can take array list also, right? Array list, like this, okay, like this. Got it? So what I'm trying to say, we have this list of list, right? You can write this here, right? And then what you can do, we can have all the nodes in the list, right? That is called graph, okay? Now what we should store, and this node is nothing but your each value of node, vertex and its length, okay? Now what is the source, right? Let's suppose we'll pass a source node. You can take from 1, we'll go from 1 to other, right? Source, like this, okay? So let's create a method name. So method name, I can take a Dijkstra, like this. I can take from here. I've already written, right? I'll go with the small letter D, and then like this. We can pass and then our graph, and then our what is called source, right? And is comma, right? Sorry, okay. Now we have to create this function. Go and create this function. You can see, right? We have this function ready now, okay? Now ready means, you can say, you don't need to write anything, okay? You can create a you can say object. So you can remove the static keyword. I will keep static keyword. Now what we should do here, first of all, we'll create a you can say distance array we can take, right? So that we'll add all the distance in this one, right? You can say we'll check, you can say current distance plus its weight, and we will put for the our neighbor, you can say, right? As we have already discussed, right? Let's go with and do. First of all, we'll create what? A distance. Let's suppose, and we'll say new int n. Now our this one is ready. Distance is ready out. Now we'll fill this distance with some value, okay? Let's suppose there is arrays method, arrays dot you can do fill, right? There is a fill method, and then you can pass you can say distance, and then there should be a default values you can pass here. So I will add the not the smallest value, but I will add the maximum value, right? Let's suppose I will go with the integer dot max value. So integer max value we are going to update, right? And further what we will do, we'll keep updating with the lowest value here, right? So let's suppose at the distance at source, distance at source is nothing but 0, because it is a source, right? It will start from here. Okay, right? No distance is here currently, like Google Map, right? You are traversing from our let's suppose your current position, and you want to go to the target distance, right? So current position, we have not covered any distance, right? That is why we have to take source equal to 0. I hope you understand, right? Then what we will take, we'll create a let's suppose a priority queue we can take, right? I will take, the name suggests, right? What happened? Priority queue. Sorry. Right? We'll take a priority queue and we'll have a node, right? Here. So let's suppose we'll give the priority queue name PQ equal to new priority queue. Okay, like this. You can remove from here also, or you can keep it, no worry. Okay, so first of all, we have created a distance. We'll have filled with the maximum integer, right? Now we have started with the source. Source is 0 because we are going to starting the distance will be 0. Now we'll have our priority queue, right? And then we'll keep adding the distance, you can say, right? So first of all, let's suppose we have priority queue. We'll add a new, you can say, a new node, right? Because we are going to start, right? The new node I will start, and this is nothing but what? Currently we are at source, right? So I will add source, and the distance is what? 0. We are at 0 distance, right? So we'll add here like this. So we have started now, right? Now while the priority queue is empty, right? When it is not empty, we'll keep updating it. Once it is not empty, it is empty, we'll return the distance, right? So what I will do, I will create not first we'll write pq dot is empty. If it is not empty, in that case we will out, right? And we'll return what? Distance array. Okay, so this is the code that we have to write, right? So when we are going to return this, we have to update the return type, right? Here. Okay, we have to return the here. Now what we will do here, when priority queue is not empty, right? It is having some value. So we have started here source and its current distance. At source distance is 0, right? This is your vertex name and this is your distance, right? As you can see, we have already created this node, vertex and distance, right? So that is why it is a new node, right? At current position, the vertex is source and its distance is 0. Okay, now what we will do, we'll poll the current pq, let's suppose pq dot poll, right? Like this. So we'll remove the element that we have put into the queue, right? And we'll say this is our current node, right? Node is current. Let me write full current. Okay, so this is our current node or vertex, you can say, that we have got. So we have poll from here, right? And then we'll get our vertex and its weight. Weight is nothing but its distance, right? So int v is nothing but your vertex. I can get from the current dot, we can get vertex, right? This is vertex. We can get, similarly we'll get its weight. I will write full WEIGST. Okay, weight. How we'll get that? Current dot distance. When you will do these things, right, you will get your data, right? Like this. But it is not required here. Why it is not required? That we will see later, right? Because we already know the distance is 0. right? So I'll take the current vertex is nothing but V. I can rename as a U, right? So I can connect U and V like that. Okay, all the U having some neighbors, right? And we will check all the neighbors. How we are going to check all the neighbors? So we can create a for loop, or before the for loop, as you remember yesterday, right? What I have did on the graph, if we'll do what, get, if you'll pass U, let's suppose, so you can get all its what we can say, list, right? You can get the list of neighbors, let's suppose. As you remember, right, it's a list of node, and I will give this as a NEIGHBORS, neighbors. Okay, so I will give this neighbors name. Now we have to make a loop on the neighbors. Let's suppose like this, we'll get a node like this, we'll get, okay, and then we will have our neighbors here, right? So when we have neighbors here, what we will do here, we'll add some value here, right? We'll get the neighbors data. We can get the neighbors details now. How? Once you got our neighbors, right, you can find which neighbor I have to go. Like if your current position, which way you want to go. So Google Map saying what, you can go with this way because it's will take your less time, less distance, right? Like it will give, right? So to implement that, first we'll get the vertex that we were talking about. We will get vertex, and vertex we will get from where, this neighbor, right? Neighbor dot vertex. You will get, similarly you will get what, its weight that we were talking about, right? We can get neighbors dot distance, right? So you have got U and V also, right? Current position to the next position, next node, right? We can say neighbor node. Now we have to check what we have to check. So we'll do compare. How we are going to do it? Dist at what, U. Dist at U plus means current position plus its weight. It's never weight. If it is less than dist at V, if it is less than, are you understanding what I am doing? Distance at U plus weight, right, is less than dist at V, right? Means there is some value at V, right? If it is less than, in that case, what we will do? We will update the distance. Remember how? Distance at U we will take and its weight and will add to the neighbor, right? Remember, right? We'll update to its neighbor, right? Then we'll add this distance to pq dot add, and this is nothing but your what, new node, and we'll add two things. First, vertex, right, neighbor vertex, and its distance at U, sorry, V, its distance. I think you understood, right, what I have done here. Let's recall again. As we have talked, right, what we have talked, we were saying, so the shortest path algorithm, the first algorithm we are going to discuss, that we have discussed, sorry, is Dijkstra algorithm, right? So in the Dijkstra algorithm, we have to find the shortest path, right? And to find the minimum distance between two nodes in a graph, right, we have to see which type of graph is this, what is the requirement is there, right? Several things we have to see, right? So when we are talking about the Dijkstra algorithm, right, so it will work only when the distance are non-negative, that we have talked. Then what we have talked, the Dijkstra algorithm we will use to find the shortest path from a single source to all other nodes in the graph by iterating. By iterating, you can see here, right? Why we are going to iterate, right? We are iterating here, right? By iterating, selecting the node with the smallest known distance, you can say. If it is the smallest one, right, then we'll keep adding the value, right? We will update the distance to its neighbor, right? So we are updating the distance here to its neighbor. You got my point? What we will do, like we have to find the from the source. We have to find from the source. You can see here we have source. This is our source. Source position is 0, right? So from a single source node to all other nodes, right, in the graph, we will do iterating, right? Iteratively, we will select the node, right? We will select the node, and then we will go with the smallest known distance, right? How? Like this, a smallest known distance. If it is smallest one, then what we will do? We will update the distance to its neighbor. See, we will update this distance, right, to its neighbor, right? And then we will again add this the priority queue so that it will keep updating, it keep iterating all the nodes with the smallest distance. It will keep updating the distance to its neighbor, right? And similarly go on. Once it is done, all the nodes will return the distance, right? And to see the distance, what you have to do, whatever it will come is, it will come in the array, right? You can hold here and you can say output like this, okay? And this is your what, you can say for loop, right? You can make a for loop on the array and you can print it, right? Which way we have to go, right? So I hope you understand this video. If you have any doubts in this video, please ping me in the comment box. And if you really like this video, please hit subscribe this channel, so I will keep updating all the videos, right? But I have a humble request to all of you. Please see all the videos that we have in this series, and we are going to add more videos. Like I will add for Bellman-Ford algorithm, Floyd-Russell algorithm, A-star algorithm, and we have BFS we have already seen, right? So where is the practical use cases we have, right? So when we are talking about the Dijkstra algorithm, it is a GPS navigation system we have, right? Where we'll use to find the shortest route, like Google Map, right? You can use a iPhone we have, right? iPhone user also have GPS system, right? That you can use, right? So GPS navigation system we will use to find the shortest route, and there we will using Dijkstra algorithm, right? Then we have a Bellman-Ford algorithm, like in the where we will use the Bellman-Ford algorithm, like in the networks. When networks with the variable delay, right? Like routing the communication network, right? That place Bellman-Ford algorithm will come, right? When we are talking about the Floyd-Russell algorithm, right? So Floyd-Russell algorithm will use in the shortest path in the dense graph. Let's suppose like a certain network analysis we have to do, right? There we will use. We'll discuss more in the details, but those things we have to do. When we are talking about the A-star algorithm, right? So it is also for path finding, like in the AI, especially in the video games, right? Those things. And you know the BFS, right? So BFS is to find the shortest path in an unweighted network, like a social network analysis, right? So we'll see that in the next video. And if you really like this video, guys, please hit subscribe this channel, so I will keep updating the playlist, right? And if you like this video, you want to continue, please write the comment there, so I will keep adding more videos in this playlist. Okay, so if you'll talk about the space complexity, time complexity, right? So time complexity, it will happen if I'm going to write here, let's suppose I'll write here. Okay, so time complexity, if we'll talk about, it is O of you can say V and plus E, right? And then you can take a log V, and this is your time complexity, right? Why? Because we have used what? Priority queue. Remember, we have used priority queue, right? In the priority queue, right, we were adding what? All the nodes, right? Then in the nodes, we are adding what? Vertex and its distance, right? And here we are also checking these things, right? So it will take log V, right? Where V is the vertices, E is the edges, right? In the graph, right? So where we will use this Dijkstra algorithm, you already knows where we need GPS system, right? So thank you guys, thank you for watching this video. Please hit subscribe this channel. Thank you.
Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel and